guys.
Yo, welcome to Calculus. This is a MOOP math course here, using the textbook James Stewart Calculus Concepts and Contexts. So, it's going to be the entire book. This is a really good book. I'm not sure what version is currently out. This is version 4. I bought this maybe 9 years ago. Let me just go and get my power cable. 1 second. We're back. So the contents of this course is going to be, first we have a preface, then a note to the student, a diagnostic test, then a preview, functions and models, limits and derivatives, differential rates, applications of differentiation, integrals, applications of integration, differential equations, infinite sequences and series, vectors and the geometry of space, vector functions, partial derivatives, multiple integrals, and then finally vector calculus. So preface goes through what's new in the edition. Has a lot of problems you can solve. To the student, it says, study hard, don't be a doob, do your homework. Calculus isn't as hard as you think. So this is the diagnostic test to determine how good you are at math. So let's go through that right now. I'm going to try to get a better camera eventually. But this is just figured I'd start it off because nothing to do today and been wanting to do this for a while. It's the diagnostic test. Hopefully you can read my pen. So this is just an algebra test to calibrate how far along you are. So this is evaluate each expression without using a calculator. I guess 1A will be down here. Without using a calculator. So you have -3 to the power of 4. It's going to be 3, 9, 27, 81. So 81. Then you have -1, 1, -1, 1. Because you have 4 negative ones. So it's going to be positive 81. This is testing how you do powers of a negative. So B will be -3 to the 4 without a bracket. So when you have no bracket around -3 to the 4, it's almost as if you're saying -3 to the 4, because exponentiation becomes before multiplication. And in this case, this is equal to also like -1 times 3 to the 4. So up here you do inside the bracket first. Bracket has highest priority, but exponential has higher priority than multiplication, such as here. So this would be -81. Okay, now you have 3 to the -4, which is equal to, all the negative means in the exponent means that you have, it's an inverse, so it just means you have 1 over 3 to the 4, which is equal to 1 over 81. That's all the negative means. So this is just testing your knowledge of exponents. Okay, then D. Here you have 5 to the 23 over 5 to the 21, and you're probably like, oh no, how on earth am I going to do that without a calculator? But luckily you can do this. 5 to the 23 minus 21. So when you have this case, you can do this, because it's equal to, because this is the same as writing 5 to the 23 times 5 to the negative 21. It's the same expression. And when you have, up here, when you have a to the b times a to the c, it's equal to a to the b plus c. So using that rule, it's just 5 to the 23 plus negative 21 equaling 5 squared equaling 25. So not too hard. E, here you have a fraction, 2 over 3 to the negative 2. So here the negative means you can just flip the fraction. So 3 over 2 to the 2, because up here again, if you have 1 over a to the negative 1, you get a, and if you have a to the negative 1, you get 1 over a. So here we have, essentially, this is actually equal to 2 to the negative 2 times 1 over 3 to the negative 2. Because when you have a to the b times c to the b, you can do a times c in bracket to the b. So we're just using that here. So you have 1 over 2 to the 2 now times 3 to the 2. So back up here it's 3 over 2 to the 2, and you just do both of it is 9 over 4. You just square both of them, 9 over 4. That's how you multiply fractions. You just would do 3 times 3 over 2 times 2, 9 over 4. So yeah, if you have any questions, leave a comment. I also offer private tutoring for $30 US per hour. There's an email below. You can reach me at, or if you have any questions, just email me the questions and I'll answer them in a video. But to an extent. Anyways, F. So we have 16 to the negative 3 over 4. So when you have a fraction in the exponent, a to the 1 over b, or 1 over b, not 5. A to the 1 over b equals the bth root of a. So that's just how you put it in the exponent form, because doing the bth root of a is the inverse of doing a to the b. It's the b, like the bth root, like the b to the bth root. That's a cool way to say it. Anyways, 16 to the negative 3 over 4 equals 1 over 16 to 3 over 4. 16 is 2 to the 4, so inverse that. 1 over 2 cubed equals 1 over 2 cubed is 1 over 8. So again, pretty easy. If that didn't make sense, leave a comment and I'll explain it further. Okay, now for 2, simplify each expression, write your answer without negative exponents. So I'll write that down. Simplify each expression, write your answer without negative exponents. So a root of 200 minus root of 32 is equal to so to simplify this, you can take values out of the square root, because root of a times root of b equals root of ab. So here we can take out a root of 2, so root of 2 times root of 100 minus root of 2 times root 16. So You can just keep taking roots of 2 out. This is 2 to the 5. But the root of 16 is 4. So yeah, actually no, this works because root of 100 is 10. That's 10 root 2 minus 4 root 2 equals 6 root 2. There we go. That's as good as it gets for that one. You can't simplify it further than this because it's a constant times a irrational root. And that's the best way to express an irrational number is by the square root, if it's a square root, that is. Or either that or by a constant like e or something, or pi. Anyways, b. So now we have 3a cubed times b cubed times 4a b squared squared, which is equal to, again, 3a cubed b cubed. So then you square the entire bracket in this case, so it would be 16 times a squared times b to the 4. So then you multiply all the like terms, so the constants, 16, 32, 48 times a to the 5 times b to the 7. Look at that. That's as good as it gets. What the hell? I have like a pizza stand on this one. I was eating pizza. Can you see it? Right here. I like me pizza. Okay, C. 3x to the 3 over 2 times y cubed over x squared y to the negative 1 over 2 to the negative 2. This is equal to, so right away we have square root in the x, inverse square root in the y cubed, x squared, one constant, and all this whole thing to the negative 2. So right out of the gate you can apply the negative. You could apply the negative 2 in one step, but just to make it more easy to follow, I'll do it in 2 steps. So negative just flips the fraction. So you have x squared times y to the negative 1 over 2 times y cubed. 3x to the 3 over 2 y cubed. So that'll just be to the 2 now. And then you have x to the 4. So when you square something, it's like adding it twice. So it'd be negative 1 over 2 plus negative 1 over 2. So it'd be negative 1. So y to the negative 1. I'm pretty sure. Yeah, you add them. Yeah, I'm positive. Okay, y cubed. It's you just multiply it by 2. Yeah, that's how it works. Okay, then you have 3 squared would be 9. X to the 3 over 2 would be x cubed. Yeah, it takes away the square root, that makes sense. Y to the 6. Okay, this equals, then you do the, since you're dividing by something to the power of something with the same base, you just subtract. So you get x to the 4 minus 3 is just x. Y to the negative 1 minus 6 is y to the negative 7. Oh wait a minute, times y to the 6. Negative 1 times 6 is y to the 5 plus y to the negative 1. Well, wait a minute. This is a mistake. This should not be here. This y cube should not be here. That's a mistake. This is a mistake. Okay. So yeah. So the y cubed. So this is right now, and this is right. Okay. So it's all right now. It'd be x squared. It should be x to the negative 1 up here, actually. Oh, wait, never mind. Who squared this? Okay, this is right. This is right. X. My bad. My bad. We're good now. X. We are good. Pardon the scratches. Okay, y to the negative 1. That is y to the negative 7, actually. Divided by 9. So the best way to put this would be, because it wants to have no negative exponents, it's x over 9 y to the 7. There we go. Squeeze d in right here. 2x plus 3 squared equals, this you have to do a FOIL, so it's 2x plus 3 times 2x plus 3 equals, you can do the Pascal triangle. You know the Pascal triangle, so this is a plus b to the 0 equals 1, a plus b to the 1 equals a plus b to the 2 equals a squared plus 2ab plus b squared. I'll do a separate video on this triangle later. A plus b cubed equals a cubed plus 3 a squared b plus 3 a b squared plus b cubed. I'll do a whole video on this later. It's kind of blurry, but I'll try and increase the quality soon. But hopefully, or maybe I'll try writing bigger. I'm just gonna get some water, 1 second. Okay, I'm back. So, it's gonna be, you can do it this way, you can just do it, you know, the standard way. So you get 4x squared plus 2x times 3 is 6x, so you get 12x, it's that twice, plus 9. And that is, wait a minute, what the hell am I doing here? D, there's no D. This is, whoops, that was 3D actually. Okay, it's 3D. So that's 3D. 3 is expand and simplify. Expand and simplify, yes. You have A is 3 to the x plus 6 plus 4 times 2x minus 5. I'll try to write it a bit bigger, that's better. You can actually read that. This is equal to 3x plus 18 plus 8x minus 20 is equal to 11x minus 2. So you always put the higher power of x further to the left. Like in this one, it's x squared here, x, then the constant. The constant is like saying x to the 0, which is just equal to 1. So it's like the x to the 0 term. It's a standard polynomial communication form. Okay, B. We have x plus 3 times 4x minus 5. This is equal to 4x squared minus 5x plus 12x minus 15 equals 4x squared plus 7x minus 15. So that's that. This is probably much easier than 1 and 2. This is just the diagnostic algebra test. So you should have learned all this stuff grades 1 to grade 11. At least in Canada, that's a standard high school math curriculum. And then we had in grade 12 we had pre-calc and then calc. So this would have been learned in pre-calc, and you should know all this by calc. But chapter 1 of this book is pretty much pre-calc. So if you're feeling lost, just hold out for the whole first chapter, and then you should be able to do it. And also, if you have questions, you can always email me, and I'll try and answer them in a video, or I can give you private tutoring, so we can talk about that over Discord or Skype. Or if you live in Ottawa, Canada, I can meet you. But you know, the odds of that are pretty low. Pretty big city. Anyways, what am I saying? What am I saying here? What am I saying? Let's go back to the math. Okay, well, where were we? We're at 3C. Root of A plus root of B times root of A minus root of B. So this is called the conjugate. And this just removes the root from the equation. So you get A, root of A times root of A, which is just A. Root of A times negative root of B, so negative root A, root B. Then you get plus root A, root B, so these two cancel. Then you get minus B. It's equal to A minus B. So whenever you have A plus B times A minus B, you get A squared minus B squared. And so in this case, A was root A, B was root B, so you just get A and B. Okay, we did D on the previous page, so let's do E now. X plus 2 to the cube. We'll use the triangle here. 1, 3, 3, 1. So this will equal x cubed plus 2x squared plus 4x plus 8. There you go. Oh wait, this is times 3. Equals x cubed plus 6x squared plus 12x plus 8. There we go. That's how that works. Drink some water here. Okay, now we have 4a. (4x squared minus 25). It wants us to factor each expression. So you get I think you can get 2x plus 5 and 2x minus 5. You can factor it like that. Let's just make sure. 4x squared was the same as this. You'd get yeah, that's how you'd factor that. That's as good as it gets, I'm pretty sure. B you get well, B, the question is 2x squared plus 5x minus 12. And you get, so in this case you need to find something that multiplies to, first put in standard form. So this equals x squared plus 2.5x minus 6. So that's to add to 2.5 and multiply to -6. So if it's too hard to do that mentally, you'd use the quadratic equation. But let's try and do it mentally. So A times B equals -6. A plus B equals 2.5. So 1 times 1.5 equals 1.5. That's not it. 5 times 0.5, it's 2.5. That's not it. 5 or -6 and 1. That's -5. -12 and 0.5. Yeah, I don't know. I'm gonna use the quadratic equation. It's too hard. So x equals b squared plus minus the root of. How does it go? Let me Google this. It's -b plus minus the root of b squared minus 4ac over 2a. Which is equal to -2.5 plus minus the root of 2.5 squared minus 4 times -6. Yeah, we're gonna get imaginary roots for this one. All of it divided by 2 equals 2.5 squared is 6.25. Actually, no, this is good. Plus 24. That's gonna be a really weird number. I'm pretty sure I didn't screw this up. I think they wanted you to do one question with the quadratic equation, just to make sure you know it. So this is gonna be the root of 30.25. I'm going to solve this real quick. Alpha, Wolfram alpha. -2.5. Oh wait, I'll just write solve. Plus 5x minus 12. Okay, apparently it's x equals -4 and x equals, so x1 equals -4, x2 equals 3 over 2. Does that make sense? Yeah, it actually works. Damn. Yeah, it fits these two. Damn. Damn. Wasn't that complicated actually. I couldn't think of that. So that means the root of 30.25 is like a nice whole number. So root of 30.25 is 5.5. So 55 squared equals 3025, and 5.5 squared equals 30.25. Okay, that's not too hard. Okay, that's the end of that. Full C. You have x cubed minus 3x squared minus 4x plus 12 equal to, here you have to do division, or you can do a double thing here like this. So you have x squared times x minus 3, and then you have negative 4 times x minus 3. So you know it's going to be x squared minus 4 times x minus 3. That's pretty easy. Okay, d x to the 4 plus 27x equals x times x cubed plus 3 cubed. So I'm not sure what to do with that. I think you can do this. Is this x minus 3 cubed equals wait a minute. This is how it works. So you get x times x, you get x squared minus 9 times x plus 3 equals x cubed. No, it doesn't work. That's as good as it gets, I think. We put in Wolfram Alpha, see what it thinks. What does Wolfram Alpha think of this? Okay, apparently you can take out, you can further factor this. So let's just put it back the way it was. You have, yeah, x equals negative 3 is a factor. So you can do, because when you put negative 3 into this bracket, you get 0. So that means you can divide this by x minus 3. So times something. And this something will equal x minus 3 being divided into x cubed plus 0x squared plus 0x plus 27. So x goes into x cubed, x squared times negative 3 times x. So then you get x cubed minus 3x squared minus it zero minus you get 3x squared plus 0x. Okay, x goes into this 3x times, and you get 3x squared minus 9x, and you subtract it. So you get 9x plus 27 is 9 times. 9 times this is 9x. Negative 27. Wait a minute. This thing's messed up. Something's not right here. It should be. Let me try again. X goes into x cubed, x squared times, and you multiply this by this. Subtract it, x minus x cubed equals 0. Oh yeah, here we go. It's 3 negatives. There we go. That's where I messed up. This is messed up. Okay, then so negative 3x. Negative 3x you get. Let's look at this. Negative 3x you get negative 3x cubed plus 9x. Let's minus this equals 0, negative 9x plus 27. There we go. Then you subtract this and you get 0. So question mark. So the final answer is x times x minus 3 times x squared minus 3x minus 9. That is fully factored. Okay, I'll be right back.